Once again, good morning to everyone. Today, after understanding what is the trend in electronegativity of group 16th, today we go to the other trends. Other trends are important than the what we learnt in our previous session, because in the previous session we learnt about more of a physical in nature, physical trends. Now we will go to chemical trends. In the chemical trends, the most important trend is oxidation state. Why? Because it is the state where loss, gain, share, coordinate of electrons will come to know. That means group 16th members or group 16 elements, whether they prefer to give or take or share or to coordinate. Even if they are ready to give, how many they give? So they are ready to give, they are ready to donate. But how many electrons they are ready to donate? So that again depends upon the electronic configuration and the need. Therefore, giving with how much, that is important. That's why oxidation state plays very important role in the chemical trends. Therefore, the first trend under the chemical property is oxidation state only in every group, whether it is S block, P block, D block, F block. It is the OS, it is the ON. So once we understand the ON or the OS correctly, so we can around guess what type of products are what are going to are going to form. Okay, that's why. So OS is very important. So we start the oxidation states of group 16. So today, what I have done, I have directly brought from the textbook, because textbook I found beautifully has explained. Therefore, I have gone to the directly textbook. So whatever content is there, it is just because of what? Textbook. So beautifully you will have explanation and we will understand. Okay, right. So this is our today's slide to discuss. So in the meantime, I go for a few more slides if time permits. Okay, right. Physical properties. Okay. So under the physical trends, after the physical trends, some physical properties are normally they tell about the solubility, boiling point, melting point, okay, freezing point. So all those are data. So density. So once we come to know all these, we can go for the purification method or the distillation method. So all these physical properties are useful where we carry out some techniques of purification, techniques of separation. Okay, sometimes to understand the bonding physically, especially with respect to the van der Waals force of attraction. So physically we can understand. That's why physical properties are 20% important and 80% chemical properties. So the data is before you regarding the melting point and the boiling point, all those. So only thing is about the polonium only we worry, because it is a radioactive, which is the byproduct of radioactive decay of thorium. So all those we learnt in the previous session. So except that, remaining all data you can go through. Okay. So wherever it is applicable, you can make use of those data. So in the future, so where you come across all these what chemicals, they are called as industrial chemicals, or if you are in the organic chemistry, they are called as petrochemicals. Petrochemicals. Yeah. Oxidation states and trends in chemical reactivity directly from textbook. Electronic configuration. General electronic configuration NS2 NP4. Noble gas, next NS2 NP4. That means we have 4 electrons in the P. Taking example, oxygen 1s2, 2s2, 2p, 4. 4 plus 4, 8. Atomic number 8. So in the 2p4, 2p2, 2px2, 2py1 and 2py, 2pz1. So they have 2 unpaired electrons, right? So if 2 unpaired electrons are given, if 2 electrons are given to 2 different shells of 2p, they go for pair up, they go for the chemical property. That means oxygen is ready to accept electron. Okay. So when two electrons are taken by the oxygen, it becomes O2 minus. O2 minus. Because oxygen is small in size and its place is just close to carbon, therefore, and it is towards the right side of the modern periodic table. So by seeing all these, so we expect oxygen to gain only. Gaining dominates over the accepting. So 99.99 it accepts electron, the two electrons. Therefore, whenever we see oxidation state of oxygen, it is always, I am using the word always, -2. This is confirmed last year also under the chapter redox reactions, where under the small topic oxidation number. So, and the second small topic was how to assign, how to calculate oxidation number of an atom, of a molecule, okay, using some data. There we learnt rules for assigning oxidation number. That time we maybe second or third rule, I exactly don't know the number, but one rule was oxygen always shows -2 ON, and it is the second most electronegative element. So minus is expected and it will show minus only, but only with fluorine, number one place. Only with fluorine, as usual, what we studied in the 11th class and in the previous session, it has to show plus. There is no chance for oxygen to show minus or the negative oxidation state or the oxidation number. So when the opponent is very strong, so we have to adjust according to his need. Like that, fluorine is the number one with respect to electronegativity. So topmost, it is taken as 4 on the Linus Pauling scale. So 4 is the highest electronegativity we have calculated till now. That is it, only fluorine. So when the fluorine is the topmost, so there is no second thought. So we will close our eyes. So when oxygen and the fluorine combines, fluorine will be the negative part and oxygen will be the positive part, and those compounds are called as oxyfluorides or fluorides of oxygen. Okay, depend upon the loss and gain, we call it as a fluorides of oxygen. So except with fluorine, okay, it will show in most of the cases uh, -2. But sometime in some cases, in rare cases, are there are some oxides from the oxygen family. Okay, so normally we have everyday day-to-day example normal oxides. They are called as what common oxides with -2. So O2 minus is a normal oxide. Whereas in some cases oxygen forms peroxide also, and oxygen also forms superoxide also. So whenever it forms peroxide, that time it will change its role under ON. That time we will have -1. Okay, abnormal. It is called abnormal uh, oxidation state of oxygen. That's why whenever we come across peroxides, they are slightly unstable compared to the other normal oxides. Best example is there before us only. Oxide of hydrogen, H2O. Oxide of hydrogen peroxide. We say oxide of hydrogen or hydride of oxygen. Both are correct. Whenever we study hydrogen chapter, there what we use the word H2O is called as what? Hydride of oxygen, because chapter is hydrogen. So which chapter we are studying, that word will use. Whether it is a hydride of oxygen or oxide of hydrogen, we call it as what? Water. So water
Sir,
is
group 16 elements will not show odd oxidation number, sir.
odd
Odd
means what?
oxidation.
Odd means what?
-1 +3 like that, sir.
They are they odd?
Yes, sir.
Oh, that means according to mathematics, 1, 3, 5, 7.
Yes, sir.
Here we will not consider that part. How many lost electron is here? How many that is we will discuss. Okay. So 1 loss minus 1, 1 gain, one gain minus 1, 1 loss plus 1, 2 loss minus 2, 2 gain plus 2. So
In
normally
textbook it is
odd is less,
yes.
because you see the electronic configuration, it is 2s2 2p4. It is 2s2 2p4 in the case of oxygen, first member. So to become normal, it has to accept 2. So how what becomes 2s2 2p6. So 2 minus 1, rare case I told, abnormal. It is abnormal ON of oxygen. Okay, that's why I was explaining about when you compare the stability of water H2O with H2O2, H2O2 is very much stable, very much stable. Every day we deal with water. So highly stable oxide of hydrogen is water, that is H2O, where we have O in minus 2 state. Whereas in the peroxide, which is unstable, so most of the peroxides are unstable only, whether it is sodium peroxide, barium peroxide, and hydrogen peroxide. Those peroxides we use to prepare oxygen actually. One of the methods of preparation of oxygen is what? Using peroxides. Because peroxides are unstable, easily we can handle with less amount of energy, with less amount of effort. We will get oxygen from the unstable peroxides. Okay. So only in the peroxide we will have minus 1, and in the superoxide it is minus half. Fractional, please recall redox reaction, where we have fractional oxidation number, some cases, okay, carbon suboxide,
Average oxidation.
carbon suboxide. So there we had in the 11th class, we learnt a small one small paragraph about the fractional oxidation number. But here in the case of superoxide also they will show fractional oxidation number, but they are all unstable. So for the normal life, for the common, for the comfortable life, we deal with chemicals which are stable. So among the oxides, it is the normal oxides, common oxides, where oxygen is in the minus 2, they are all stable. Okay. So this is what regarding the ON of oxygen. So as an individual or with someone, how it is behaving. So that is only what trend in the oxidation state of especially oxygen first member. But when you go to the next member, sulfur, selenium, all those, so they will show not only minus 2, they also show plus 2 also, plus 4 also, plus 6 also, because as we move down from the top to bottom, so electronegativity decreases. This we have seen the trend yesterday only, previous session. So they become more of a metallic. So losing becomes more and more what dominating factor at the bottom. So therefore, as we move from top to bottom, electronegativity decreases or electropositivity increases. So thereby they prefer to lose electron. Accordingly, they become plus 2, plus 4, plus 6. But when we see at the bottom, extremely at the bottom, by looking to the electronic configuration, NS2, NP4 or 2S2, 2P4. Okay. So S electrons are what? They are not made busy in the bonding. They will show inertness towards the chemical behavior, chemical reactivity or the oxidation state. Therefore, those two electrons are not taken into account. Only the electrons which are there in the P, 4 electrons. Okay. So sometimes two are lost, only two unpaired. So along with one period, one period is made what a loss by strong energy. So 4 by chance when two electrons of the S are made used under special case once again, then 2 plus 2 plus 2 6. That's why it is plus 2 plus 4 plus 6. Plus 2 due to the two unpaired electrons which are there in the 2p, plus 4 all the electrons of the 2p are NP in general, plus 6 when plus 6 along with the p orbital, s orbital also takes part in the bonding. So that's why what we can conclude that other members except oxygen, when we move from oxygen onwards downward, so there we have plus 2 plus 4 plus 6 dominating. Okay. And whenever we have what OS, that is oxidation state, or the ON, higher OS, that is plus 4 plus 6, they have got high polarizing power. This we have understood in the Fason's rule under the chemical bonding chapter. So because they have the high charge, so they can easily polarize. That means they can go for a sharing of electrons. Instead, to go for the transfer of electron. Therefore, the compounds which are there in the higher OS, plus 6 more, plus 4 less. So they are covalent in nature. They are ionic. So they develop covalent character due to what? Due to the high polarizing power of the high charge of group 16th members, especially from sulfur downward. At the bottom, it is plus 4 only. Okay, so due to the inert pair effect. So this all is the trend what we see everywhere. It is same trend: inert pair effect at the bottom, shielding effect in the middle, in the beginning no d orbitals. Same reasons are there in every group. Once we understand one particular group about the normal trends, same type of answer or reasoning you can supply for the remaining groups also. Here also oxygen is abnormal. First member, it not only shows the properties of its own member, it also shows the properties of the other members also. Okay, so it's slightly different. This I have told in the case of nitrogen, first member of the 15th. In the same way, in the 16th also, first member is anomalous, first member is abnormal. So that also is there at the second paragraph of the today's slide. That is what? Anomalous behavior of oxygen. Reasons same. Reasons same. Oxygen is small in size. Oxygen is high electronegativity. Oxygen is high ionization enthalpy. Oxygen is what? There are no d orbitals. Okay. So when there are no d orbitals, it cannot expand its covalency beyond a certain limit. So beyond 4. Okay. So going for covalency which is equal to 6 is impossible for the oxygen due to the non-availability of d orbitals. So though it is Kali, so it's very difficult to promote to that level with large amount of energy. Whereas in the case of other members, so 3 principal quantum number entries there: 3s to 3p4, 4s to 4p4, 5s to 5p4, and so on. So that means when 3 entered, the principal quantum number in the case of sulfur is 3. It is 3s to 3p4. So 3s2 is there, no 3 is there, 3p is there. So when 3s to 3p is there, 3d has to be there. So 3d is khali is there, it is there. But in the case of oxygen, there is no d at all. There is no d at all. It is 2s2, 2p4. So d enter starts from principal quantum number 3 according to the last year's quantum number chapter, where we have learnt 4 principal quantum number orientation, all those. Therefore, because the 2d is not there, then the question of what going beyond 4 in the case of oxygen doesn't arise, or impossible for the oxygen. That's why it is abnormal or anomalous. So all the anomalous properties are because of these 4 reasons. Same 4 reasons for the fluorine also. Next member. So in the next group. So all these, right? Okay. Now, next what? Same he told. The absence of d orbitals in oxygen limits its covalency to 4, and in practice rarely exceeds 2. On the other hand, in case of other elements of the group, the valence shells can be expanded and covalency exceeds 4. That means expecting 6 is possibility in other members, but with oxygen impossible. Straight away we can say impossible. Okay. Now after understanding what OS, oxidation state, now let us apply the knowledge of this OS to the chemical properties. Okay. So the first property is what? First property is reactivity with hydrogen. 16th member with hydrogen. O hydrogen. S hydrogen. Se hydrogen. So all with hydrogen. Okay. So what is the trend here? All the elements of group 16 form hydrides of the type H2E. What is here? E is any member you can take from the group 16. So H2O, H2S, H2Se, H2Te, H2PO. But most common are H2O and H2S. So H2Se, as we move down, slowly stability what becomes less stable. But H2O, H2, H2S is you have seen in the laboratory. H2O every day. H2S we will prepare in the laboratory when you enter the laboratory in the 12th class. So when conditions prevails, so the time you will prepare H2S actually. So the same H2S you will use for the qualitative analysis. So because H2S is the one of the reagents for confirming uh, radicals in the qualitative analysis, that is called salt analysis. In the 11th class we have not done. In the 11th class it was only on the virtual mode, but 12th class we are eagerly waiting for the time to soothe. In the time soothes, certainly we will enter the laboratory and we will do the practicals. So H2S is there. We have prepared many times in the past, and we are using. So H2S is prepared. So if gas is having highly unpleasant smell, no. So what we will do? Sometimes we will pass the H2S in water. So we convert the H2S gas into H2S water. It is called hydrogen sulfide water. It is soluble. Okay. So then we use it for the qualitative analysis, either in terms of gas or in terms of H2O water. So H2O dissolved in the water is called as H2S liquid or H2S water. So that all will learn in the practical only, not in the theory class. Okay. So what is the general trend here? So we get hydrides of the formula H2E. Okay. And some properties of hydrides are given in the table 7.7 that you go through, because they are all physical data. So just have for the knowledge, whenever we conduct practical, the time they will find some use or meaning. Otherwise, just have a glance. So the acidic character increases, okay, from H2O to H2TE. Acidic character means what? The ability to give hydrogen. Okay, water gives easily hydrogen because O is most electronegative. Because O is electronegative, so it withdraws the electron between the bond, so thereby creating the poles. Then release of hydrogen becomes very easy, whereas the electronegativity decreases from the top to bottom. So when it is decreases, we don't expect the polarity. So all those reasons are there. That's why he is saying that acidic property, what their acidic property increases. Okay, from H2O to the H2T. At the bottom, we don't have any acidic character at all. Okay, so the increase in acidic character can be explained in terms of decrease in bond enthalpy. One more reason. So bond enthalpy. So that means the bond between the what hydrogen and the group 16 members becomes lengthier because of what? Because of increase in the size. Oxygen small in size, and top to bottom size increases due to the creation of extra shell. So bond length increases. So decrease in the bond enthalpy, decrease in the electronegativity. So you can combine all the reasons and tell that acidic character, what what he says, the acidic character increases from top to bottom, or from H2O to H2TE. Okay. Now, owing to the decrease in enthalpy for the dissociation of He bond down the group, the thermal stability of hydrides also decreases from H2O to H2PO. So because you can rupture, you can break, or it can dissociate easily. So because of all these reasons, so hydrogen can be removed so easily from top to bottom. That means hydrides are slightly unstable at the bottom. So stable hydrides we will have in the beginning only, and the best hydride in this family is what? Water. Water is the most common solvent. Water is the best oxide of hydrogen, and water is the best hydride of oxygen. All these credit goes to H and O combination. Okay, all right. Because of the water, life is, once again I am repeating, life is there on the earth. So there are conditions who are supporting. So formation of water, formation of air, some 13.4 billion years ago. Slowly, so we have evolved. So what we are today is because of what? 13.4 billion years ago conditions. So when the life supporting system is there, we survive. Okay, otherwise no life on earth. Okay, but life is there. We're enjoying. So kindly go through the table. Just have a glance. Then what we'll do? So we'll go to the second chemical trend, or second chemical property, that is reactivity with oxygen. First, number what? Oxygen. Oxygen to oxygen, no meaning. Okay, so except first, so we'll go to the second member. So they form oxides. Okay. So oxygen is available in air. So second major component. Therefore, I told in the beginning only, most of the ores or most of the minerals in the lithosphere or in the metallurgy or in the geography. Okay, so they are available in the oxide form only. Okay, because oxygen is available. So all metals are reactive metals except noble metals. Okay. gold, platinum, silver, all those are noble metals. They do react, but not like other metals. So because metals are reactive and because oxygen is available in the atmosphere, so naturally we expect that metals occur in the earth crust in the combined state, that too in the form of water, oxides and the sulfides, both are there in the same group, that is the 16th group only. So therefore, what is the trend here? Not only 16th member, any member with oxygen use oxide, but the formula depends upon what? Formula depends upon the oxidation state. Okay, right. So that is the here explained here. EO2, EO3, all those types of oxides are possible. So regarding superoxide, peroxide, we don't learn. Only about the normal oxide we learn. So only superoxide, peroxide, we have learned in the 11th class just to calculate the ON, and in some what in chemical bonding, where we have drawn the molecular orbital theory MOT. So to draw the energy level diagram to show O2 minus O1 minus O half, all those you have drawn and compared what anti bonding and the bonding. Otherwise, normally we don't come across superoxides and the peroxides. Most of the time we deal with normal oxides. So today, so we'll wind up the this class. Again, a small work is there in the school. So I think very easy, small topic. So if at all any doubts are there, I will wait for about 1 or 2 minutes, and automatically I will wind up and go to the class. Okay, the school building. Yeah. So anything regarding today's session, most welcome.
No, sir.
Directly from textbook. Okay. So today you read the textbook. Whatever sentences are there, only to understand. Okay. So sometimes we will be a teacher. Sometimes we will be a felicitator only. We will felicitate. So what is given in the textbook? So it is a
Sir,
multiple roles we have to perform. Sometimes you are the teacher. Sahu became teacher for me to make a co-host. So it is a learning, teaching is a two-way traffic. Okay. So that means I am concluding. Okay. So remaining part we'll discuss Monday. So Monday is the lengthier class I am going to take because most of the work is over. Monday
Okay,
is
sir.
totally free. So Monday will take a long, little bit more important topics. Till then, have a nice time and have a weekend. But take
Thank
care.
you, sir. Okay, good morning, sir.
Very good morning.
thank you, sir.
Sir,
Yeah, please.
sir,
Tell.
sir, my doubt was regarding that sample papers.
Sample paper. You said
Yes,
no. You said no. Okay, okay.
which they released, no, sir.
It
Same
is,
format will be followed.
I am also trying to
Same,
download, but it is saying something. I will ask
sir, we can
someone.
download. We can download, sir. Link is there in groups.
Is it which group?
12th B group, sir.
Okay, okay. I'll do. Okay, I'll do.
Sir, that same format will be followed, sir.
Same. The purpose of
But
giving is
total marks is more, no, sir.
more.
Sir, 35 marks, sir, but 45 questions, sir.
Total
Because
marks is
somewhere
more, sir.
half, somewhere one. It is more of
No,
a
sir, they
objective.
told
No, sir.
equal
For
marking.
every question they give 1 mark, sir. 60
Maybe they have
questions are
given
there.
internal choices, more of choices.
No,
50
sir,
questions
like
they have to attempt, sir.
Is it?
there are 3 sections, sir.
Uh,
And in first section, there are 24 questions, attempt any 20, sir. And in
ah,
second section, 26 questions, attempt any 20.
that means you are
And
well.
in last section, they told to attempt 5, sir. Means total 45. You should
Oh,
attempt.
okay. Good. No, when you are given chance
But
to select,
it is of 35 marks, sir.
Means
They are
marks are more, no, sir.
why marks are more?
for every question they are giving 1 mark, sir.
Correct. See how much is required. You have to explain. No, let us not go in detail. This is a answer in brief and to the point. Maybe that is the idea behind CBSE. Answer in brief and to the point. Let us not go lengthier. That
It's
may be
MCQ,
the
no, sir.
why this is made, so that in the second term any corona case once again increases, so this is the final test only. That's why you take this test very seriously. So study whatever chapters are completed. I am going to complete one more topic also. Aram say you can score 90 plus aram say easily. Anyway, I will see and I will discuss. Okay, don't worry. Okay, okay. So thank you Vaishnav and thank you Sandeep.
Thank you, sir.
Yes, sir.